All right, this is section 6.7, lesson A. We're going to talk today about solving radical equations. So these are going to be equations that have square roots or cubic roots in them. You can see this assignment here is going to be out of the textbook. Okay. Essentially, a radical equation is one that includes a radical symbol in it. And we're going to talk through this three-step process here for how to solve radical equations algebraically. Okay, now what's going to happen in these types of equations before we get into the process of how to do this is it's possible that our solutions may be what are called extraneous solutions. And here's what an extraneous solution is. It's a resulting solution to an equation that if you were to actually go back and check the solution, it is not actually a solution to that equation. Okay? And so what this essentially means is for these particular problems, when we do get an answer, we always want to make sure that we're checking our answer, because it's possible upon checking it that that answer will get thrown out, and then we would essentially say that our answer is no solution. Okay, so I'm going to show you how you'll be able to check your answers. We're going to use a graphing method to check our answers, but the method we're going to use to solve the equation is going to be algebra. Okay, so here's what we want to do with step number one. Okay, step number one, what we want to do is we want to isolate the radical symbol on one side of the equation. Okay. Now notice it mentions here that if there's more than one radical symbol, you want to isolate the one that is more complicated. Now this first example that we're going to talk through, you can see there's only one radical symbol. I'm going to go ahead and just kind of put a box around that radical symbol. So what we're wanting to do is we're wanting to get just what I put the box around by itself. So that means we need to take this 4, we're going to move that 4 to the other side so that the only thing that is on the left side of the equation is in fact that radical symbol. Okay, now we've talked before about how to get rid of a radical symbol. We said whatever the index is here, we know this is a square root, you would remove that by squaring that side, and so we're going to do the same thing to the other side of the equation, and that is going to remove the square root symbol, leaving you with x plus 2 on the left, positive 9 on the right. Okay, now with the square root symbol gone, we can finish solving this equation for x. By moving the 2 to the other side, we get x equals 7. Okay, now here's where we have to be careful. It's not an option to check your answers. You have to make sure that you check them, because there are occasions when these will be thrown out. Okay, there are really two ways for you to check your solution. Let me just first describe for you what this solution should represent graphically. Your solution should represent the x-intercept of your graph. Okay, that's the x-intercept. So if we talk about, your graph, however that graph might look, we would expect where that graph's crossing the x-axis should be directly in line with what we're saying our answer is. Okay, now what you can do, a quick way of checking this is instead of looking at the graph, what you could do is you could use the table feature and see if when x is 7, and I know I didn't draw this graph right at all, the y value should in fact be a 0 if that's really the x-intercept. And so what you're going to do on your calculator is you're going to go back to the original problem, and you're going to move everything in the problem to one side. So you wouldn't have to write this on your paper, but what you would type into your calculator is you would type in the square root of x plus 2 plus 4, and then you would need to make sure that you subtracted this 7, brought it over to the other side. If you wanted to combine these together and make it a -3, that's fine, or you could just type it in like this, but it needs to be typed in so that everything in the equation, including the 7, has been all moved to one side of the equation. Now, instead of graphing it, what you can do is go into Table Setup. Okay, you're hitting the second key first, Table Setup, and you want to start your table out, start the table in Table Setup at an x value of what your answer is, at an x value of 7. Okay, then you're going to go directly into the table. You're going to hit second graph, and what you should see when you do that is across from the 7, you should see a 0 right here in the y column. If you see a 0 in the y column, that's confirmation that your answer when x is 7 is actually an x-intercept. Okay, this is how you can check your answers. So essentially, you're plugging the whole equation, everything moved to one side, into y1. You're going to start your table out at your answer, then you're going to go into the table and check and see if there's a 0 there. If this was anything other than a 0, we would throw this answer out, we would write no solution. Okay, now let's go ahead and look at one that's a little bit more complicated. What makes example B a little bit more complex is you can see in this equation we have two separate radicals, square root of x minus 12 and then just a square root of x. Now notice in step number 1 it talks about isolating the radical on one side of the equation, but it says if there's more than one radical you want to choose to isolate the radical that is more complicated. So I'm going to put the box around the radical that is more complicated. That's the square root of x minus 12. I'm going to make sure that that is what I'm getting on the left side by itself, which means I'm going to need to take this square root of x and I'm going to subtract that, bring that over to the right hand side of the equation with this 2. Okay, my focus right now is to remove this big square root symbol right here that's over top of the x minus 12. Okay, so what I'm going to do is I'm going to square the left side, and because the entire left side was over top of a square root symbol, when I square it, that removes the square root symbol and leaves me with x minus 12. Now, on the right side, I have to group the entire right side in parentheses and also square that. Now, here's where you have to be careful. This entire right side is not underneath one big square root symbol like this was. So, when you're squaring a quantity, because there's subtraction here, technically I need to write this out twice, and I'm going to apply the FOIL method. I'm going to distribute the 2. So I'm going to go ahead and write my left side of the equation here again. Okay, if I distribute the 2, I'm going to have a 4 minus 2 times the square root of x. Okay, now I'm going to distribute a negative square root of x to each of those terms, so I get another negative 2 square root of x. Now be careful here. This is a negative square root of x times another negative square root of x. So two negatives are going to make a positive, and essentially we're squaring the square root of x because we're multiplying it times itself, so that's going to give me just x. Square root symbol is going to cancel. Okay, so let's see if we can clean up a little bit here on the right side. Okay, these do not cancel. In fact, I have negative 2 square root of x, and I'm going to subtract another 2 more square root of x. That's going to give me a total of minus 4 square root of x plus x. Okay, now let's look at our steps here. It says we just did this. We raised each side of the equation to a power equal to the index of the radical to eliminate the radical. Well, that got rid of the radical on the left side of the equation, but it says now to go ahead and repeat steps 1 and 2 until all of the radicals are eliminated. You'll notice in this problem, we still have a radical symbol. So I'm going to put a box around that radical symbol, and now I'm going to go back up to step 1, and I'm going to repeat the same process. I need to remove everything that's on the right side of this equation so that just this radical that I put the box around is by itself. Okay, so let's talk through this here. I'm going to get rid of this 4, so I'm going to subtract 4 from 12. I'm going to get rid of this x, so I'm going to subtract x. Now look at what happens here. Okay, right now, this x that I just brought over cancels out the x that was already there, so that's gone. I now have negative 16 on the left, but be careful, there's still this negative 4 that is in front of this square root of x. Okay, now remember, we are focusing on trying to get this square root of x by itself. So I'm going to divide both sides by negative 4. I'm just going to carry this work over here. I now have positive 4 on the left side, square root of x on the right side. Okay, it took a lot of things we were trying to get rid of on each side of the square root of x. We moved everything over until we finally got that square root of x by itself. And what we're going to do now is we're going to square that. We have to square this side of the equation as well. We end up getting 16 equals x. Okay, now remember, before we automatically circle this as our answer, it's possible that this answer is actually an extraneous solution. So what we're going to do on the calculator is you're going to go back to this original problem. In y1, you're going to type the original problem, but make sure that you've moved everything to one side of the equation. So this 2 that's over here, I'm bringing that over here to the left side. By subtracting it, that's where this is coming from. You're going to type this whole thing into y1, and then you're going to start you're going to go to table setup and start your table out at your answer, x equals 16. Okay, then go into the actual table, hit second and the graph button, and what you're looking for is it'll give you in the x column, that's a 16, you're looking to see, are you seeing a 0 in the y column? That's indicating that when x is 16, that is actually an x-intercept. And I don't believe that you actually see a 0 right across from the 16, which means 16 is an extraneous solution. We're going to throw it out, and we're actually going to write down that our answer is no solution. Okay, no solution. All right, we're not going to do this example 2. And at the bottom, this right here is really the alternate method that we were using to check our solutions. We are going into the table and we're checking to see if the given x values have a y value of 0. That's how we know whether to keep it or not. Okay, we're going to just a couple more problems. We're going to pick up the pace a little bit here with doing this. I want to look at this example C right here with you. Okay, now sometimes when you see a problem, instead of seeing a radical symbol, you might see a fractional exponent. And we've learned that when we see a fractional exponent, that's really a radical in disguise. So I'm going to go ahead and just kind of put a box around this quantity that has the fractional exponent on it. That's my radical that I'm trying to isolate. And I'm going to gradually move things to the other side of the equation until that's by itself. Okay, so I've got this 3 out in front here. Okay, the 3 needs to be removed, so I'm going to go ahead and divide both sides by 3. Okay, now, if you're more comfortable changing this into a cubic root of 5y minus 1, that's not a problem. You can totally do that. Okay, because we do have to ask ourselves, how are we going to get rid of this fractional exponent 1/3? Okay, what I really want is the exponent here to be a 1, not a 1/3. Okay, so one way of doing that is to take this left side, and if we were to cube the left side, think about what 1/3 times 3 would be. That would cancel each other out, and that would essentially leave us with just 5y minus 1. Okay, so if we do that, then that means this fraction 2/3 that's on the right, I would also need to cube that. Okay, you want to think through here that what you're doing when you're cubing 2/3 is you're distributing that exponent to the exponent on the 2 and on the 3. So that makes that a 2 cubed, which is an 8, over a 3 cubed, which is a 27. Okay, now I have no fractional exponents, I have no radicals. My focus is to try to solve this for y. So I'm going to go ahead and add 1 to both sides. Maybe here you would want to pick your calculator up and on the calculator type in 8/27 plus the number 1, switch it back into a fraction, you get 35 over 27, and then divide by 5. Instead of dividing this fraction by 5, I'm going to multiply by the reciprocal 1/5, and if I type that into my calculator, switch it back into a fraction, initially I get as my answer 7/27. Okay, now this particular problem, everything was already moved to one side. See how the whole thing was set equal to 0? So you're going to just type this whole thing into y1. Once you get that all typed into y1, you want to go into table setup and type in that you're going to start your table out at an x value of 7/27. Once you've done that, go into the table, hit second graph. You're looking to see, do you see a 0 across from, now technically speaking, I know this was using a y here instead of an x, but this is technically acting as our x variable, if you will, here. So we're starting it out at an x value of 7/27, and we would want to see a y next, or 0 next to it in the y column, and you should actually see that. Okay, we're going to try one last problem here. We're going to look down here at example 3a. Okay, we're back to showing these as radicals. I'm going to go ahead and put a box around that. I'm going to gradually get this by itself. So we're going to move that 6 over, and then we're going to divide by 3. We always want to isolate that radical symbol first. Okay, now that that's isolated, we get rid of radicals by raising them to a power. So we're going to raise each side to the 4th power. That will remove the radical symbol, and then we just use algebra to finish solving this. Okay, this is the important thing that we don't want to forget, and it always reminds you this in the directions. It says check by graphing. Okay, again, this is nice. Everything's already moved to one side. You're going to go back to this original problem, type the full original problem, all into y1, starting our table out at 5, checking to see if we see that the y value is a 0. Okay, I believe when you do that, you should see a 0 in the y column. That means we are keeping that as our answer. Okay, once again, your assignment is out of the textbook, which you should see a screenshot of this on my webpage, but it's from page 181, 18, 19 through 25, and odd, and 28.